Hello, CP Algebra 2, and welcome to another lesson here. Today's topic is how do you simplify radicals with an index greater than 2? Remember that this little number here is what we call the index of radicals. Some things to remember here. If we have a product of radicals, we can split it up into two little radicals. So multiplication here just says that we can take the index of the same of those and both of them, kind of breaking them up. For example, if you had the square root of 24, we thought of this in the past as the square root of 4 times the square root of 6. The square root of 4 becomes 2. You have the root of 6, and that's how you leave your answer. The square root of 72 is thought of as the square root of 36 times the square root of 2, which gives you 6 roots of 2, and so forth. The key was you wanted to look for perfect squares if you had the square root of those. Also, with division, you can take a big square root and exchange it for two little square roots, or nth roots. Square root of n index square root of a, and n is your index over the square root of b. You can write it like that. For example, if you had the square root of 4/9, you could split that up as the square root of 4 over the square root of 9 and have 2/3 as your answer for that. Another example, say you had the square root of 7/25. You could split that up as the square root of 7 all over the square root of 25, which would be square root of 7/5. Those were just different examples for that there. Now, writing these in simpler form, and whenever you have a different index, for example 3, you just want to remember that the radicand does not contain a factor in which you can take out the nth root. And the denominator has also been rationalized. No radicals in the denominator, meaning that you can't have 1 over like square root of 5. That is not allowed. The rat in the denominator. So your goal here is, if you had to break up square root of or cubic root of 750, the goal is to know the perfect cubes. Okay, if you don't know some of these would be handy to write down. Things that 2 to the third is 8, 3 to the third is 27, 4 to the third is 64. If you were to find other ones like 6 to the third, I'll type that in my calculator, 216. Okay, so those are all things you should know. Now, the idea is to try and see, does 750 divide by 8? No. Does it divide by 27? No. 64? No. But it does divide by 125. All right, so what you can think of this one is that the cubic root, I'll write it over here, sorry. Cubic root of 750 is also the cubic root of 125 times 6, the cubic root, and the cubic root of 125 is just 5 cubic roots of 6. Instead of looking for perfect squares, you're looking for perfect cubes in these examples. Tricky is for those that don't know their perfect cubes, which is okay, but please get to know them. For example, let's try out the cubic root of 16. So here are the perfect cubes up here. All right, so let's think right off the bat. We know that that could be 8 times 2. So cubic root of 8 times cubic root of 2. Cubic root of 8 is 2, and then this is just going to stay the same. So we have 2 cubic roots, 2. Next one here, so let's try out 5 roots of 128. Again, so now we need fifths. What times itself 5 times? If you need to just think of things, so like 2 to the 5th is 32. Let's try dividing 128 by 32. Oh, hey, that works out. So we would have the 5th root of 32 times the 5th root of 4, because 32 times 4 equals 128. And the 5th root of 32 is 2, and then you'd have 5 roots of 4. Okay, that's basically how you need to go about, is trying to recognize one number times itself 5 times or 4 times. In this example, 4th root of 1053. Okay, so it's a good idea to try out like what's 2 to the 4th. We know that's 16. Try out 3 to the 4th. We know that is 81. 81 does go into 1053. So we can think of this as 4th root of 81 times the 4th root of 13. The 4th root of 81 is 3. And then 4th root of 13 from there. That's how you would write your answer for that. The 8th root. 8th root of 32805. Again, try out from the bottom. 2 to the 8th is 256. 3 to the 8th is 561. And try and divide those into 32,000. It does come out that 3 to the 8th would work. So if you take the 8th root, and I'll write this one just a little different, of 3 to the 8th, and we multiply that by the 8th root of 5, okay, really it's just 3 to the 8th, again, is 6561. You end up with 3 times 8 roots of 5. Cubic root, 135. If you want to try this one on your own, so 2 to the 3rd is 8. Does that go into it? I don't think so. 3 to the 3rd is 27. So we can think of this as a cubic root of 27 times a cubic root of 5. Cubic root of 27 is 3 cubic roots of 5. And again, these are your answers. Another example. Examples always help. Cubic root 12500. 5th root, sorry. It's always a good idea. If you see something to the 5th, why don't you try out something? So let's try 5 to the 5th. And that is 3125. If we divide that in, it does work out. So we know that the 5th root of 5 to the 5th, and you would have to multiply that by 4, because this times 4 equals 12500. You end up with 5 5th roots, sorry, of 4. Okay, so it is very important that you try and get to know and understand your perfect cubes and everything from there. Okay, so that's the first part of these particular problems for today. So try out some of those, and nice stuff.